Hello, Mathalinong learners! Gandang araw! Welcome to TV Eskwela. I am Teacher Ian Grace Badang Lagumbay of Pantukan National High School, Pantukan North District. And I will be with you as you learn another interesting lesson in mathematics for grade 9. For today's episode, you will learn how to simplify radical expressions using the laws of radicals. Previously, you learned about rational exponent and radical expressions. Let us remember that the exponential expression a raised to the m over n can be expressed in radical form as nth root of a raised to the power of m and vice versa. In nth root of a raised to the power of m, n is the index which gives the order of radicals, and a raised to the power of m is the radicand, the number within the radical sign. Also, let us recall what are the laws of radicals. The laws of radicals are the following. The nth root of x raised to the power of m is equal to the quantity nth root of x raised to the power of m. If we have the quantity of fifth root of x raised to the power of 6, then it is also equivalent to fifth root of x raised to the power of 6. The nth root of x times the nth root of y is equal to the nth root of the product of x and y. For example, square root of 3 times square root of y can be also written as square root of 3y. The nth root of x divided by the nth root of y is equal to the nth root of the quotient of x and y. When we have square root of 3 over square root of y, we may also write it as square root of 3 over y. The nth root of x raised to the power of n is equal to x. For instance, cube root of z cubed is equal to z. Again, we will apply those laws of radicals to simplify radical expressions. But how do we know if the radical is already in its simplest form? Here is what we must remember. A radical is in its simplest form if, number 1, the radicand does not contain a perfect square, cube, or nth power. Number 2, the index of the radical is the lowest possible index. Number 3, there is no fraction in the radicand or no radical in the denominator. Let us practice simplifying radicals to master this skill. The things I mentioned earlier will serve you as our guide. So let's go! Let us simplify the following radicals. Example number 1. Fourth root of 25 equals fourth root of 5 squared. Let us change fourth root of 5 squared to exponential form and reduce the rational exponent to lowest term. That will be 5 raised to 2 over 4 equals 5 raised to 1 over 2. Then changing 5 raised to 1 over 2 to radical form leads to square root of 5. This is in the simplest form since the radicand is not a perfect square and the index is the lowest possible index. Example number 2. Eighth root of a raised to the power of 12. Let us find a factor of the radicand that is a power of 8. That will be 8th root of a raised to the power of 12 equals 8th root of a raised to the power of 8 times a raised to the power of 4. Then, find the 8th root of each factor. We have 8th root of a raised to the power of 8 times 8th root of a raised to the power of 4, which is equal to a 8th root of a raised to the power of 4. Changing the radical to exponential form makes a times a raised to the power of 4 over 8. Reduce the rational exponent to lowest terms results to a times a raised to the power of 1 over 2. Then, changing it back to a radical form gives a square root of a. This is the simplest form of 8th root of a raised to 12. Let us now proceed to the next example. Example number 3. Square root of 4a squared, b raised to 4, c raised to 6. This radical can be expressed in exponential form as quantity 4a squared, b raised to 4, c raised to 6, raised to 1 over 2. Note that 4 equals 2 raised to 2. So, this is equal to 2 raised to 2 over 2, a raised to 2 over 2, b raised to 4 over 2, c raised to 6 over 2. Simplify the rational exponents leads to 2ab squared c cubed. Seems difficult, but it isn't, right? As long as you don't forget the prerequisite knowledge and skills, there's no need to worry. What about this next radical? Example number 4. Cube root of negative 54 x to the 4th y to the 8th power. As you observed, the radicand is not a perfect cube. So, we will reduce the radicand by finding a perfect cube factor. A perfect cube factor of negative 54 is negative 27. That is, quantity negative 3 cubed multiplied to 2, x raised to 4 has x cubed times x as factors, and x cubed is a perfect cube, and y raised to 8 has y raised to 6 as perfect cube factor times y squared. Let's factor out the perfect cube. So, cube root of quantity negative 3 cubed x cubed quantity y squared cubed times cube root of 2x y squared. Now, simplify the perfect root. We have negative 3 xy squared cube root of 2x y squared. This is now the simplest form of cube root of negative 54 x raised to the 4th y raised to the 8th power. As you can see, in the final answer, the radicand has no perfect cube. Example number 5. Square root of 75 over 36. By quotient law of radicals, this can be expressed as square root of 75 all over square root of 36. Since 75 is not a perfect square, we will reduce this by finding a perfect square factor. Can you find the perfect square factor of 75? Yes! 25 is a perfect square factor of 75 multiplied by 3. So, square root of 75 equals square root of 25 times 3, or by multiplication law of radicals, is equal to square root of 25 times square root of 3, and square root of 36 equals 6. Then, square root of 25 times square root of 3 all over 6. Since square root of 25 equals 5, therefore, square root of 75 over 36 equals 5 square root of 3 over 6. Example number 6. Square root of 18x cubed over 49x y squared. We can start by simplifying the radicand. X is a common factor between the numerator and denominator. Since 18 is not a perfect square, we will find a perfect square factor. And 9 is a perfect square factor of 18. If we factor out the perfect square, the expression is now square root of 9x squared times 2 all over square root of 49y squared, which is equal to 3x square root of 2 all over 7y. Since square root of 9x squared equals 3x and square root of 49y squared equals 7y. Example number 7. 1 over square root of 5. How do we simplify this? Simplifying this kind of expression is called the process of rationalizing the denominator. Remember that there must be no radical in the denominator. In this case, to eliminate the radical in the denominator, we may multiply square root of 5 on both numerator and denominator. Through that, the denominator will become a perfect square. Multiplying square root of 5 on both numerator and denominator is equivalent to multiplying the fraction by 1. Therefore, there will be no changes in the value. So, 1 over square root of 5 multiplied by square root of 5 over square root of 5 becomes square root of 5 over square root of 25. Finally, we have square root of 5 over 5, which is already a rationalized quotient. Let me emphasize that to rationalize denominator, you have to multiply the numerator and denominator by a number such that the resulting radicand in the denominator is a perfect nth power. Example number 8. 5y over 4th root of x. Since there is a radical in the denominator, This needs rationalizing the denominator. What do we multiply fourth root of x to make the radicand a perfect fourth power? Correct! We may multiply this by fourth root of x cubed because the resulting product will be fourth root of x raised to the power of 4 and is equal to x. So, we will multiply both numerator and denominator by fourth root of x cubed. Therefore, 5y over fourth root of x equals 5y fourth root of x cubed over x. Now, what if the denominator of the expression is a binomial and has a radical term? Consider this next example. Example number 9. 3 over square root of y plus 2. The denominator is a binomial with the first term, a radical. What do we do then? In this case, we need to multiply both the numerator and denominator by the conjugate of the denominator. What is a conjugate of a binomial? The conjugate of a binomial is a binomial of the same terms, but of different sign of its second term. The product of the radical expression and its conjugate is an integer or not a radical. Finding its product is the same procedure in multiplying the sum and difference of two binomials. Like quantity x plus y, quantity x minus y equals x squared minus y squared. In this example, the conjugate of square root of y plus 2 is square root of y minus 2. This results to y minus 4 in the denominator, which eliminates the radical. We will multiply both the numerator and denominator by square root of y minus 2. The solution will be 3 over square root of y plus 2 equals 3 over square root of y plus 2 times square root of y minus 2 over square root of y minus 2 equals 3 square root of y minus 6 over y minus 4. Therefore, 3 over square root of y plus 2 equals 3 square root of y minus 6 all over y minus 4. Did you get all our examples? You can find more examples and discussion in your self-learning modules. You may further explore the concept you learned today with the links provided in the e-search section. Also, evaluate how much you have learned about this topic by accomplishing the activities and checking them with the answer key. So, it has been a Math Gandang Araw and you've learned about simplifying radicals. Another day proves that nothing can stop learning, not even a pandemic. Again, this is Teacher Ayan Grace Badang Lagumbay of Pantukan National High School, Pantukan North District, saying, dito sa TV Eskwela. Sa pag-aaral, sama-sama. Bye-bye!